Everyone's attention back. You guys are going to have to implement a mic sharing protocol. I'll let you debate on how you want to do that. While everyone gets set up, yeah, please take a seat. There's a few seats here in the front, so if you're sitting at the back and you're tentatively considering sitting down for the talk, please come forward. No one's going to be offended that you walk around during the panel. So we're going to talk about wallets, dApps, and general mitigation. So I'm going to start by doing a quick introduction about myself and frame the discussion for the panel. So I'm Stefan at the GoStep. I'm a founder, a steward at Flashbots, and I work on a lot of the architecture. I spent a lot of my time before joining Flashbots thinking about how to improve the UX of Ethereum, how to improve the applications that are built on top of it. And that's one of the parts of MEV that I find closest to my heart, which is how do we make sure that the user outcomes that the protocols that we build take into consideration MEV and allow us to create systems that benefit these end users? What are the creative things that we can start to build if we have an MEV-aware system? So I'll go through quickly, and maybe you can say your name, which project you're from, and then we'll get into how that all relates to MEV afterwards.
Cool, yeah. Hi, I'm Felix. I'm the technical lead on Cow Protocol. And should I introduce the protocol, or do we do that later?
We'll get into that later.
Okay, cool.
Hey, I'm Sam. I'm with MakerDAO. I work on the protocol engineering team.
Hey, I'm Skeletor. I'm from the Yearn Finance team, and I work on MEV protection and on-chain automation.
Hi, I'm Simon. I work for Consensus as a blockchain ecosystem advisor.
Hi guys, I'm Alex, founder of Block Wallet.
Okay, great. So we have representation from Wallet, we have representation from protocols, and we have some middleware. I don't know if you would brand yourself as a middleware or as an aggregator, but that's MEV focus, as well as Consensus that, of course, has all kinds of different projects in the space. I think one of the places that I want to start is with the protocol developers. I think for a long time, there wasn't activity on Ethereum, and that was kind of the glory days of MEV because you could kind of pretend that it didn't exist. But as soon as the activity started arriving, all of a sudden it elucidated a lot of the challenges that MEV brings to protocol design. So maybe with MakerDAO first, can you talk to me a bit about how MakerDAO's journey through understanding MEV has been and which part of the protocol design that you guys think about it?
Yeah, sure. So back in the day, the glory days, as you say, of not having to worry about MEV, Maker used to run an English auction system where people would have to have capital on hand to bid on the auctions. There was basically no DeFi at that point, just basically MakerDAO, Uniswap Compound, and some other stuff. But the ecosystem was really early. But I mean, our view on MEV is it's a really useful tool for us to basically. Well, let me start with the auction switch, I guess. So partway through, we upgraded to a new auction system. We're using a reverse Dutch auction now, so we can settle the whole thing immediately, as opposed to having this capital lockup requirement with the previous one. So this is really useful, and especially with the advent of flash loans, we can basically democratize sort of access to these liquidation events. So that was a really good step forward. So yeah, MEV is the tool there that sort of really helps us to not have to worry about having keepers with lots of capital and stuff like that.
I have a question for you. I don't remember what the name is. Was it Black Thursday or something like this that happened with MakerDAO? Do you want to maybe explain what happened there and how that relates to MEV?
Yeah, so Black Thursday, I think everybody remembers that. Fun times. I remember the call, actually, when that came up. I think we had a max capacity governance and risk call that time, and I think everybody in the ecosystem was watching and hoping we could get through it. So basically, what happened was ETH dropped, I think, about 50% in value in one day. And during the cascade of liquidations, this was under the old system. There was an exploit where somebody could basically mass bid, zero bid on all the collateral. And so the idea was that the chain was so congested and people were not ready for this that they were able to succeed in stealing, well, I don't know if you want to call it stealing. They took they took for free like I think it was about $5 to $10 million, which was a lot at the time. So we had to debate basically whether we were going to, actually I wasn't working at Maker at that time, so I was just watching as a community member, but they were debating whether to have to trigger a global shutdown at that point because the protocol was in a danger zone. But we squeaked through, we took the loss, the community rallied together and actually purchased the newly minted MKR to cover the loss. And we survived, and I think we're stronger now for it.
To me, this was such a fascinating story, and Flashbots was founded a few months after this event took place because we realized that there was a lot of education to be put into the space around MEV, and I think iterating the auction design in such a way that allows for liquidations to happen more efficiently is a key way that apps have to think about mitigations within the design of their system. Maybe with Jörn, can you talk a bit about the MEV journey there and how you consider that in your protocol design?
Yeah, absolutely. So up to your point, we do also have like systems in place, let's say, to take care of our CDP in Maker for our ETH strategies, for example. And we also, like in the golden days where there was no MEV, the chain was always working perfectly, there was no clogging, etc., etc. We only had like CryptoKitties that one time, really long time ago, and now everything was fine. We never ever thought that we were going to need a system where we could like push transactions through, and we would know at which block and with which parameters they would get into. Which on these more risky strategies, it's a must to be able to tend the strategy properly and not like push losses back to the users. Besides that, basically with how strategies work in Yearn is basically you farm some random token, then you dump that token to your underlying token. And that specific interaction can be done either manually or through automation, through Keeper Network. Both of those back at the time were extremely vulnerable to MEV. Basically, they had 100% slippage store level, so you can basically sandwich the entire rewards of a harvest or of a profit transaction. We obviously saw that, and we say, okay, somebody at some point will exploit this. And since we were extremely swamped with work, we say, okay, when at least we have one people that is going to be exploiting our strategies, we'll start working on it. We had that event rather sooner than later, way previously to Flashbots, etc. And we decided to, obviously, first step, move back everything to be done by hand, close up all the automation, and then put up a lot of contracts in place to be able to force keepers to go in through like a stealth transaction relayer, which forces them to use a private mempool that, let's say, if their transaction becomes publicly available, we can slash that transaction and they will lose like a certain amount of Ether, which should be kind of the reward for the searcher or the person like looking out for our like harvest or something like that.
Do you want to talk a bit about the tools that you explored and how you went about implementing these tools into Yearn?
Yeah, so basically this stealth transaction type of contracts is something really generic. Anyone can grab it and put it out on their own. It's completely generic. We also have a ton of tools built around the Gnosis safe to also protect transactions that might have or might be vulnerable to MEV. Putting up Gnosis Guard, which was introduced in one of the latest versions. We also do a lot of monitoring, and we use Tenderly for a lot of our sandwich alerting. So we simulate, whenever we have a transaction doing a harvest, we simulate that transaction if it was the first one, like index 0 on the block, and then on the real transaction, and we see if any of the state changes, and we have like a whitelist of state changes that we monitor to see if we got like properly sandwiched or not.
So you mentioned stealth transactions.
Yeah.
Tell me how that works. How does the integration work there? Because I think this is going to be an interesting lead into some of the discussion with the other panelists. I want to know from a dev perspective, yes, it's great to be able to send transactions directly to a miner to bypass the transaction pool. Tell me a bit about the integrations, maybe what are the pain points of it?
Yeah, so basically we are protecting against two main attacks. One of them is obviously your transaction being sandwiched, so somebody gets that from the public mempool. So for that, we are routing this or making the sender route this transaction with a secret hash that they need to randomly generate. If that hash becomes publicly available, then anyone can report the hash, and the transaction will not revert if the hash is reported, but it will self/slash itself, sending a part of the reward to the one that reported the hash. Secondly, we also, after doing this, we say, okay, yeah, but we can also get uncle attacked, and this is when uncle attacks started happening, and says, oh yeah, this is obviously it was going to be a mistake. So we added as well some block number protection. So whenever you send a transaction, you need to send the block number on which that transaction needs to be included, and if not, it will effectively revert. You can have this on Flashbots, but even though Flashbots will add your transaction on a specific block, that transaction can still be uncle replayed because the protection is not at the MEV level. So even if you have, let's say, two blocks, one is Flashbots block and the other one is not, your transaction will be available on the uncle block, and it can be stolen and replayed in a subsequent block with +1 height from your block. So there is a UX, it's basically an UX pain in the ass because you need to broadcast a shit ton of transactions, one per block. So what we do is basically we broadcast 10 transactions with the same nonce with different block numbers and let Flashbots do the hard lifting. So thank you for that. And yeah, it's not that we are DOSing or anything. Those are pretty tiny transactions, etc. But what we are most excited and worried about is reorg attacks and all of this kind of stuff that would really break the system. We do have some improvements in place, which is we moved all the swapping mechanics out of the strategies and into a new system where we would do, or we would route most of the trades internally. So we would do a lot of co-swaps, etc., which are less prominent to be attacked.
Okay, cool. So I hope this gives sort of a taste of, implementing MEV mitigations, in particular stealth transaction, still requires a lot of developer effort. And it's not at a place today where it's super easy. I think one of the interesting things in the last years that I've seen is, I thought, Flashbots would launch a private transaction pool that users would be like, finally, I have a way to not get sandwiched. I have a way to protect my transactions and get good inclusion. Turns out users had no idea that they were getting sandwiched in the first place, and it's really protocol developers who realize, oh wow, there's this new tooling now that I can integrate into my stack. I want to move to maybe a layer above the DApp, and that would be the wallets and aggregators as well. How did you guys? Let's start with Block Wallet. How did you guys start encountering MEV, and how did you think this is something that we need to build features around?
Sure. So first disclaimer is that we're using Flashbots as an option to users in our wallet to basically avoid sandwich attacks on Uniswap and most popular dexes. I think it all started from there. We were developing, and we had a community for the last year. We launched our wallet 45 days ago. But throughout the time when we were developing, I think the whole Twitter space got exposed. I think the most prominent discussion about MEV attacks and stuff is sandwich attacks, right? I think that's where the average DeFi user is aware that high slippage can cost him money. So we ended up, to us it was a simple UX solution, right? Offering users with extra value. So yeah, I think we're the first wallet to integrate Flashbots as an option. And yeah, I think some of our users are using it. They love it. We love it too. So it's a great experience so far.
Okay. I think this is one thing that I didn't think would take so long to implement. It seems like having more optionality for the user to decide on where they route their transactions makes obvious sense to me. But it's taking quite a while for wallets to integrate. I'm going to call out the consensus representative. One of the longest standing issues on the MetaMask GitHub is please allow the user to define a way to have their own RPC so to allow them to protect against front running. there's been a lot of back and forth and discussion, obviously, with the MetaMask team. I'm wondering where does Consensus sort of see MEV protection, MEV mitigation right now? You know, why is this sort of an issue that has taken a long time for MetaMask to react to, et cetera?
Thanks. So yeah, I joined Consensus about 3 months ago. And so my job is really to kind of identify trends or potential blind spots that might affect teams that they need to consider and advise them on them. So about 2 months ago, I started looking at MEV because it seemed like it would, you know, affect every team in Consensus. And it's taken up most of my time since then. It's a really complex issue. I'm still falling down the rabbit hole. And so the problem with Consensus is the size of the company, right? And when you're that big, you don't want to make any sudden moves because those sudden moves can have displacement effects that could have unintended consequences. So an example for that is like the question you brought up with regards to MetaMask. So if MetaMask implemented sort of front-running protection that you know, offered some sort of private channel directly to you know, block producers, then so you know, that would work. That would work really well. But then you're kind of opening up the vector for proprietary order flow, and you know, by itself doesn't really have any negative impacts. But taken into consideration with everything else that Consensus does, including like Infura and staking and everything, you could unintentionally create a centralizing force. And so I think from Consensus' point of view, where we don't want to make any sudden moves, being conscious of our size, we want to have a coordinated approach across all of the different teams. Unfortunately, that's kind of a little bit complicated, but it's something that we're trying to work on at the moment.
Do you want to talk a bit about what are sort of the key concerns, you know, that you've discovered while evaluating MEV, and maybe a framework by which you think about exploring solutions?
Yeah, so I mean, the key concerns rated in order of concern is probably the effect on the users, first and foremost, right? And especially with MetaMask, I think it's safe to say that a lot of new entrants into the space use MetaMask, and it's their first experience of dealing with like Web3 crypto. So we don't want a poor experience for them, right, from front-running or sandwich attacks. But beyond that as well is a huge concern is the centralizing force that MEV can have, right, both in terms of centralization of block proposers and block builders as well. And Alex from Flashbots did some great research in terms of an exploration of MEV in ETH2, which highlights the centralizing force of proposers. And I think, you know, like MEV Boost and PBS goes a long way to mitigating that, but it's still sort of a concern. And then block builder centralization, and I don't think it's fully understood what the implications for that are just yet. So those are the things that we're really looking at. And like we're currently establishing a framework to really understand like what those implications are, who the actors are, and like who we should be talking to. But yeah, as I said, MEV is in and of itself very, very complicated. But when you couple that with an organization that has multiple different teams that work independently, it gets even more complicated. So it's, yeah, it's a tough cookie to crack.
It sure is, yeah. And I mean, one thing that is obvious is, you know, just like there's still huge pain points in integration, some of these solutions, there's also very few solutions out there. So there's so much room for exploration and innovation to help mitigate those concerns and improve upon them. I think to bring in CalSwap, CalSwap is probably a team that has been looking at MEV protection for a long time. That's proven by the fact that you own the Twitter handle MEV protection. So can you tell me a bit about, you know, the CalSwap journey through MEV, where it became obvious that users cared about this? I think if I had to frame the discussion here, or my perspective on CalSwap is, it's taking an approach of like not just, okay, we need to solve MEV, but rather how can MEV fit into providing a holistically better experience for users. And I wanna hear a bit about you about this.
Yeah, for sure. So CowSwap actually comes from a very long journey within Gnosis, the company that Cow Protocol spun out of. And I think it must have been back in 2017 when Gnosis was considering implementing automated market makers for their prediction market outcome tokens, basically as a market mechanism. And they decided against that because they saw back then the intrinsic flaws of automated market makers when it comes to front running, sandwiching, all that stuff. And of course, that turned out to be a big mistake. They should have followed up with that. But basically, around the time when Phil published his first paper about MEV, we started thinking along the lines, okay, how can we build a mechanism where MEV is actually reduced? And one thing that I've seen also throughout the day today, kind of the themes in the space is more around the lines of how can we redistribute it MEV? How can we maybe actually make it part of the security budget or kind of other attempts? That's what I see the ecosystem focus a lot on. I think what we have traditionally done from Gnosis and Cow Protocol's perspective is really thinking how can we reduce the amount of MEV that is inherent to the protocol design and to the mechanism that we trade. And one of the ideas there was that blockchains are already discrete in time, and we already batch different transactions into a single block and then execute them all at once in a single, atomic timestamp. So why do we have a continuous time trading mechanism built on top of that discrete settlement layer? Whereas, in 2015, Eric Budish and his colleagues suggested to use frequent batch auctions, where basically you collect multiple trades and settle them in one single transactions at a uniform clearing price, kind of getting rid of that ordering problem that is kind of the source for MEV. And so I would say in 2018, we started our endeavor on the research, how can we build frequent batch auctions on top of Ethereum? And it was called Gnosis Protocol at the time, started to, it was a completely closed system where batch auctions were implemented, but we didn't really have any, we couldn't tap into the atomic liquidity layer that was on chain. And kind of the learnings that we got from there was, people don't actually care so much about the mechanism that they are using. So it's not really, you can't just live by the idea that build a better mechanism and people will follow. That doesn't really work. And so we had to think about ways of how we can overcome, first of all, that chicken and egg problem of attracting users. For that, you need liquidity. For liquidity, you need users. And also, how can we make it so that people actually care? And so the second version of the protocol then, I would say on the technical side, the revolution was that we went beyond those closed batch auctions and it actually allowed to have a thin layer on top of existing AMM liquidity, where basically we can allow to match users in batches and peer-to-peer with one another. But if there's just one person in the batch, we just basically default back to being a MetaDex aggregator and settle them with the best on-chain liquidity. So we made it kind of a Pareto improvement, if you want, for users to use our protocol. And at the same time, we combined it with a lot of nice usability features. We have this. A lot of people really like the moo sound, apparently, that comes after you trade. You don't pay for gas in ETH, you pay for gas in your cell token. So when you're just harvesting your yield coin that you just want to reinvest in the underlying, you can pay with that. And so we really focus also on making a product that is really appealing to users and not just relying on building a better mechanism and people will come. And so I think, that's the history.
Yeah, it's funny, you think that you're going to build a product that's great because it protects the user from MEV, and then it turns out that they love your product because it has a moo sound, and you're like, oh wow, well, all this engineering work was, really unnecessary here. Okay, I want to talk a bit about forward-facing things and get you guys thinking a bit about the future. So I think one trend that I'm seeing coming down the line as we move to more a multi-chain future is something that I like to refer to as domain abstraction. So it's the idea that we, as dApp developers and as wallets, want to abstract away from the user a lot of the decisions on where the transactions end up, on which domain they end up, because ultimately that's not what they care about, right? They have some intent, which is to do something else, which is maybe to do a trade and collect some other token or buy some NFT, and they shouldn't have necessarily to worry about the intricacies of what happens in the execution of this trade. I think we're probably headed towards a future in which there are more service providers that help figure out how to route these transactions and execute them in a way that hits multiple different domains. My question to you guys is, in a world where we want to abstract away a lot of this complexity from the users, what are the missing pieces of the puzzle to be able to enable that kind of user experience?
Maybe I can start from Cow Protocol's perspective. I think we're very much already steering towards that direction by basically separating the actual trade that a user does versus the execution. So basically on Cow Protocol, people just say, I want to trade this asset for that asset at that limit price, and you leave the trade execution up to a professional entity. Like in traditional finance, there would be a matching engine, and as a matter of fact, we have multiple matching engines competing for the best execution. And so in a multi-chain world, you might, okay, say where's your token come from which chain, or where do you want your tokens to end up. But if you're just on Polygon or Gnosis chain or some other side chain and are trading a large amount where the liquidity is best on mainnet, you don't want to bridge over and bridge back. But by virtue of having kind of this decentralized solver network and Cow Protocol, you don't actually have to do that. You can rely on an external market maker sweeping in that liquidity and executing it on your behalf, and those market makers can do much more smarter things than you would. They could bridge more than just the amount that's needed for your trade. They could use some predictive measures to optimize the cost for you. And so we think that we're positioned in a pretty good direction towards making this effective by having a very competitive matching engine landscape.
So with Maker, we are currently full force focused on getting onto all these different chains. We already have our own bridges deployed on Optimism, Arbitrum, and Starknet, and we're actively working to get the Maker protocol on these chains. We're big believers in the multi-chain future, and in terms of like what's needed, I think just a lot of it is just basic infrastructure. We need Maker on these protocols. We have various products we're working on to basically inject DAI liquidity into all the places that users are using. So that's a big piece that we're kind of we're working towards right now.
Are there any unique challenges that come from having Maker on multiple domains, maybe with regards to MEV specifically, that you anticipate will arise from this deployment?
So Maker's, a lot of other protocols, they sort of work in isolation, so they can just sort of take the code base, redeploy it on a remote chain. It's different for us because every time we go to a remote chain, we are incurring some risk to the core protocol and DAI. So we need to be very careful and measured where we go and evaluating the security models of these chains. They're not they're working towards progressive decentralization, all that stuff. We're not quite there yet. So setting appropriate debt ceilings for the amount of DAI that can be minted on these chains as they're in sort of beta phases is very important. That's a unique challenge for Maker,
Yeah, same. +1 on the security and reviews and etc. And also on setting up proper, let's say, safety nets for if shit hits the fan, basically. I do still believe that we are pretty young in the multi-chain kind of golden days, let's say, when everything is quote unquote safe. But yeah, and Jörn, we are also building our Vaults V3, which has a lot of functionality to be able to have users put money into mainnet or whatever chain, and us be able to route into strategies that might not be in the same chain, possibly. We were just talking at lunch about a way to let users either withdraw or deposit via signature, via whatever chain they want. That's also pretty nice. And as I said before, since we don't have that much MEV risk right now on how we build things or how the changes on the design we made, we do not incur any additional risk on the MEV side on going into these chains. We do have a lot of security risk, and we do put a lot of effort in analyzing on doing like actual safe yield farming. So yeah, I think that's still there is some improvements needed for us at least.
If you don't have anything to say, you don't need to say anything.
I think Consensus really believes in a multi-chain future. I think that's safe to say. It's inevitable. But it's interesting. One of the last panels kind of said, as a searcher, that like the chains that they prefer the most are the least centralized. And that was kind of an interesting remark. Personally speaking, in my role, a real challenge I'm finding is how do you measure decentralization on different chains? And that's something I think really needs a lot more research, right? Because people talk about decentralization, but when you really look at it, when you really look at client diversity, geographical dispersal of nodes, the amount of different developers, the activity of developers, and all of the various things that go into making a network really safe, things aren't as decentralized as people talk about, right? And I think that's really important for application developers and infrastructure providers to think about and to try to get more data so it's really transparent which networks are actually properly decentralized and which aren't.
Maybe a quick question. How are you doing on time? Is there a timekeeper? Time's up. Okay. All right. Well, thank you everyone for coming in, tuning in for this Wallet and dApps panel. I hope it was insightful and how various teams are approaching this. Obviously, come talk to them if you're looking at solving similar problems or looking at integrations. Thank you to our amazing panelists.